All right, so now we're going on to a clean slate here so that we can figure this out because it is a rather lengthy problem. So basically, we have the data at the top that we need to solve this. And the first step is to get the empirical formula from the percent mass composition. So these are the same steps like as that I've gone through before. And I'm just doing this a bunch of times because I know it's a lot of information to go through, but it's the same process each time. So basically, we're going to, again, assume that we have 100 grams just because that's easy. So when we convert, so that all we have to do is convert percent to grams. So that's 74.1 grams of carbon, 7.4 of hydrogen, 8.6 of nitrogen, and 9.9 of oxygen. And then when we do that, then we then multiply by the inverse, essentially, of the molar mass. So it's 74.1 grams of carbon times, or basically divided by 12 grams. So 1 mole divided by 12 grams. And we do it when we do it that way, grams cancels, and we end up with moles. So the moles we end up when we do this for each atom in this compound are shown at the right. And so it's 6.18, 7.4, 0.61, and 0.62. So now we're going to divide by the smallest mole value, which is going to be 0.61. So we'll divide everything by 6.61. And we end up with, for nitrogen and oxygen, it's a ratio of 1. So oxygen is 0.62, but that's very close to 1. So we can, in this case, we can round to 1 because we're looking for a whole number ratio. For hydrogen, it's 12.1, and for carbon, it's 10.1, which again, we can round off because it's going to be a whole number ratio for a formula. And so the empirical formula we end up with is C10H12NO. Now, the next step, which is the same one we've done in the past couple examples, is to get the molecular formula from the empirical formula plus the molecular formula mass. And again, it's the same way we do that. We first of all figure out the empirical formula mass. And so the empirical formula with C10H12NO. So basically, we multiply each atom in that, the number of that atom times the mass of that atom, and that gives us 162 grams per mole. So that's the empirical formula mass. And then we already in the lab calculated experimentally the molecular formula mass. And then when we divide so that's 324 grams per mole for the molecular formula mass, divide by the empirical formula mass, which we just determined, and then we get a ratio of 2. So now we're going to multiply each of our subscripts in the empirical formula times 2, and we end up with C20H24 N2O2. So the big question is it cocaine or quinine? So this is the molecular formula that we determined, C20H24N2O2, and that is exactly the same as the molecular formula of quinine. Cocaine is different, so this indicates that it is quinine that was in my garage. Okay, so let's just do a couple more examples. Let's say that what is the molecular formula of nicotine if we know that the percent mass composition of nicotine is 74.1% carbon, 8.6% hydrogen, and 17.3% nitrogen, and it has a molecular mass of 162 grams per mole. So we do the same thing here. We convert grams to moles, so that's 74.1 grams of carbon, and then multiply, or essentially divide by 12 grams because it's 12 grams per mole for carbon. And then we do the same for hydrogen and nitrogen, and we end up with 6.18 moles of carbon, 8.6 moles of hydrogen, and 1.23 moles of nitrogen. So this is the number of moles that we have in 100 grams of the substance, but we want to figure out what this is in a whole number ratio. So to do this, the easiest way to do this is divide by the smallest number, which is 1.23. So then for nitrogen, we get one nitrogen, and then we're going to end up with 7 oxygens and 5 carbons. So that's going to be the ratio, 5 to 7 to 1. So basically, then we can write an empirical formula from this information. So that's C5H7N or N1, but you don't have to write the 1 in a formula. So then the next step, same as before, is we're going to get the molecular formula from the empirical formula and the molecular formula mass. So we're going to determine the empirical formula mass. And again, we just use the empirical formula and multiply by the mass of each atom in that formula. And we end up with an empirical formula mass of 81 grams per mole. And then if we look back at the top, the molecular mass is 162 grams per mole. So we're going to divide 162 by 81, and we end up with 2. So that means that our molecular formula is twice as large as our empirical formula. So it's C10H14N2. Okay, and just one more example. Estradiol, which is a female sex hormone, and it has a mass composition of 79.4% carbon, 8.8% hydrogen, and 11.8% oxygen, and it has a molecular mass of 272.38 grams per mole. What is its molecular formula? So first of all, assume 100 grams, just like we did in the past. So that's 79.4 grams of carbon, and then divide that by 12, which is the molar mass of carbon. So that's 6.62 moles of carbon, and then 8.8 grams of hydrogen divided by 1 gram. So that's 8.8 moles, and then 11.8 grams of oxygen divided by 16 is 0.74 moles. Divide by the smallest number that we have, which would be 0.74. So that's going to be 1 oxygen to about 12 hydrogen to about 9 carbon. So from this information, then we can write the empirical formula. So again, we round off because you can't have part of a carbon atom. So we round off the nearest whole number. And for any information that I would give you, it's going to be close to a whole number if you calculate correctly. Now, if you did this in the lab and were sloppy about measuring, you might not get a whole number, and it'd be hard to figure this out, but hopefully an analytical chemist will have very precise values, and they will end up with a whole number. So the empirical formula is C9H12O, and we do the same thing again, where we determine the empirical formula mass. So basically multiply the subscript for each atom in the compound times its molar mass, and we end up with a molar mass of 136 grams per mole. And then we're going to go up to the top again and look at the molecular mass, which is 272.38 grams per mole. So we're going to divide 272.38 by 136, and once again, it looks like the answer is that it's 2. In other words, the molecular mass is twice as large as the empirical mass. So we're going to multiply the empirical formula subscripts by 2. So that's C18H24O2. Now you might have noticed in these examples that I have that a lot of them have very similar composition: carbon, hydrogen, oxygen. Some of them have nitrogen. But these are very common molecules in organic compounds that are present in biological substances. So this would actually be representative of something that might happen in an analytical chemistry lab, where you're looking at a lot of things that are very similar to each other in terms of the composition of what atoms are within the compound, but they're very different substances. So it's really important to figure out exactly what the composition is, and it's not always easy to figure out what something is just from the atoms in it. You have to figure out exactly the ratio of atoms and how many they are. So that is all I have to say about formulas. And so goodbye until next time.